ربي قلبي حبي خير رسل ربي من به أبصرت دربي يا شفيع.
وهنا سند الويل ولا حدا معاه كيس قاطبة برجعلكم اياها تخافوش. So it's a serous membrane made of two continuous layers. تسلموا لي. So this is the simplest way of peritoneum. We have a sac, okay? We fill it. It's a sac. This sac is made of simple mesothelial cells, we call them. Those are simple squamous cells, okay? Mesothelial means the cells that secrete the fluid. This sac is filled with the fluid. You close it, you put it between two movable organs. This is the stomach, this is the posterior abdominal wall, you put it here, in between them. So this, if the two structures move, organ here, they will move easily because of the presence of the fluid inside the sac. Okay? So in other words, what is peritoneum? It's continuous with itself. So it's a continuous membrane of two continuous layers that covering the abdominal organs. Now, when you put this sac between the abdominal wall and the organ, between the stomach and the posterior abdominal wall, for example. If this was the stomach, this is the posterior abdominal wall, okay? If I put the sac in between them now, part of the sac will be facing the wall, okay? The muscles and bones, okay? The abdominal wall. The other one will be facing the viscera, the viscus, the stomach, the organ, okay? So the part of the sac lying over or covering the abdominal wall, I will name it the parietal layer of the sac. Okay? The same in plural. You have parietal layer, you have visceral layer. Okay, but it is the same layer. Okay? So we have a parietal layer facing the wall, and parietal indicates the wall, it means wall. And visceral layer facing the viscera, covering or investing the viscera, okay? Or the viscus, which is the stomach. So it's a continuous, but parietal and visceral are one layer, remember. They are continuous with each other, the same sac, okay? So I have a parietal layer facing the wall, I have a visceral layer covering over the organ, okay, visceral, and in between the visceral and parietal layer, what you will have? A fluid-filled space inside the sac. And this will be called the peritoneal cavity, okay? The peritoneal cavity. So there are three structures in peritoneum. If you look carefully here, this is a cross-section of peritoneum, and you can easily see here in this cross-section, this is the abdominal wall, as you see. These are the kidneys. أستاذ وليد، أنا شايف الصفوف الخلفية كلها ورا طارق طبعا. حسب عددهم، ليش عددهم دكتور؟ أنا بيجي عندي بالورقة هون في أرقام 400 و500 حاطين.
ليش عدد كويس يا مسؤول الدفاع؟ وين مسؤول الدفاعون؟
هاي القاعة.
ليش عددكم؟
280.
280.
So if you look carefully here, guys, this is the abdominal wall, this is the stomach, this is the spleen, these are the kidneys, and if you look carefully, this black membrane is representing the peritoneal sac, which we talked about. Now, if the peritoneal sac is covering over the abdominal wall here, this will be the parietal layer. So this is the parietal layer of peritoneum. Now, once this sac starts to reflect to cover over the stomach, now it becomes what here? Visceral layer. So this is a visceral peritoneum. It covers around the spleen. It's still visceral. Then it returns back around the abdominal wall. Becomes now parietal. Okay? So it's the same thing, the same layer. Once it comes on the wall, it's parietal. Over the viscus, it is visceral. The space in between, all this space is filled with the fluid, peritoneal fluid, and we name it peritoneal cavity. Okay, peritoneal cavity. So remember, there are two terms here. There is abdominal cavity and peritoneal cavity. This is all this structure which containing the organs and the peritoneum is the abdominal cavity. Okay, all of this the abdominal cavity, but the peritoneal cavity is this space only within the peritoneum. Okay, so there are no organs in the peritoneal cavity. Okay, because only fluid within the sac, there are no organs. The organs around the sac covering around the organs. Okay, so there are no organs in the peritoneal cavity. Now the relation of abdominal organs to peritoneum, whether they are covered or invested by peritoneum or they are not. Okay, depend on the movability or on mobility of the structure or on structures that are movable and in continuous attachment to that organ. For example, the kidneys, as you see, they are fixed structure in the posterior abdominal wall, far away from the stomach and other movable structures. So they are not covered by peritoneum. They are located behind the peritoneum. So if you look, you see them in the posterior abdominal wall, only covered anteriorly by parietal peritoneum. So they call them retro, which means behind the peritoneum, retroperitoneal structures. Other structures, like the spleen, for example, yet it's not a mobile structure, but it is in close proximity to mobile organs, like the stomach. Once it expands, it will directly touch the spleen. So we need to cover it by peritoneum. So it's covered by visceral peritoneum. In this case, the spleen is, we refer to it as intraperitoneum. Okay? But remember, this is a confused or misconceptional name. Intraperitoneum does not mean inside the sac, inside the peritoneum. There is nothing inside the sac, only fluid. Intraperitoneum, it is covered completely, invested by visceral layer of peritoneum. Okay? So, if this is an organ, if it is retroperitoneum, it will be behind. Okay? If it's intraperitoneum, it will be completely covered by peritoneum, like this. So you can reflect without opening the sac and remove it. So it's just invested or covered by visceral layer of peritoneum. Okay? So this does not mean it is inside the peritoneal cavity. This means it is invested completely by visceral layer of peritoneum. Okay? So we have intraperitoneal structures and retroperitoneal structures. What about the peritoneal cavity now? If you look here in the cross section, there is something to make it much easier to study the peritoneum. Anatomists usually divide the peritoneal cavity, the fluid-filled cavity, into two parts. The main one, the largest, all this space, which extends from the diaphragm up, as you see, all the way down into the pelvic cavity, as we call it the greater sac of peritoneal cavity. It is the same. In addition to this greater sac, there is a smaller space of peritoneum that extends behind the stomach, as you see here. We added, this is easier, behind the stomach to that, so that we make the stomach intraperitoneum. If you remember, I told you the stomach continuously expand and collapse. So it's not just enough to keep it covered anteriorly. We need to cover it, become intraperitoneum from behind. So the sac, covering all the abdominal cavity here, and a little bit of it I will extend it behind the stomach. This part behind the stomach, which is in continuation with the other part of peritoneal cavity, but just to distinguish this part behind the stomach, we call it the lesser sac of peritoneum. The lesser sac of peritoneum. And you can see it here in dark green. But remember, it is continuous with the greater sac, and it is the same peritoneal cavity. Okay? But just a descriptive term. Okay? There is no functional separation. So we divide the peritoneal cavity into a greater sac, which is the main cavity, and a small part behind the stomach. We call it lesser sac. So the greater sac is the main part of peritoneal cavity, as you see all over here. All of these spaces in blue are the greater sac. This space here behind the stomach in dark blue is the lesser sac. The lesser sac, or the opening between the greater sac, the continuation between the greater sac and the lesser sac behind the stomach, this gap or this corner, this small opening here, we refer to it as epiploid foramen. Okay? Epiploid foramen or foramen of Winslow, referring to the French anatomist who described it, Jacob Winslow. So foramen of Winslow, okay, epiploid foramen or omental foramen, okay, all of these are the same, and it indicates the continuation between the greater sac. Here we cut the parietal peritoneum, we are inside the greater sac, the peritoneal cavity. And if you move your finger easily inside, behind this part of peritoneum, this is the visceral peritoneum covering around the stomach. Behind this opening here, you will get into extension of the sac. We refer to it as the lesser sac. And this here is the foramen of Winslow, or epiploid foramen. So the foramen of Winslow, or epiploid foramen, it's not a real foramen. It's just a continuation between greater sac and lesser sac. The border. This one, okay, is the connection between the greater sac anteriorly and the lesser sac behind the stomach. If you look carefully here, you see this is the stomach covered here by a layer of peritoneum and another layer of peritoneum anteriorly. Two visceral layers of peritoneum covering the stomach, so the stomach is intraperitoneal. This here is the peritoneal cavity filled with fluid completely. We cut here the peritoneum and we are inside the greater sac. Anterior to the stomach, all of this is the greater sac. You see, part of the sac we just expanded behind the stomach. So this part of the sac is the lesser sac, or this part of peritoneum, okay, the lesser sac. And this opening here between the lesser sac and all of this, the greater sac, is the foramen of Winslow, or epiploid foramen. Okay. So peritoneal cavity can be divided into a greater sac anterior to the stomach, which is the main part of the cavity, and lesser sac, a small part behind the stomach, okay, and the communication between them here is the foramen of Winslow. Now, foramen of Winslow is very important because of so many vital structures around it. So if you look anteriorly to the foramen of Winslow, you will see something we call it portal triad. What is the portal triad? Triad, three structures going portal to the liver, okay? The portal triad includes the portal vein, the hepatic artery, and the bile duct. Portal vein is the largest one, which takes blood from the intestine back into the liver to be filtrated, okay? And after it's filtrated within the liver, hepatic veins will drain it into inferior vena cava to the heart, okay? So this is the portal vein for filtration of the blood before it's returning back to the heart within the liver. Then we have the hepatic artery, which takes oxygenated fresh blood from aorta into the liver cells for oxygenation, okay? Portal vein brings blood to the liver for filtration. Hepatic artery brings blood from aorta to the liver for oxygenation, and the bile duct is the duct that secretes bile into the intestine for emulsification and absorption of fat. So these are the three portal triads. They are called portal triads because they are going directly into the liver, okay? And they are three structures always together. This is the portal triad. If you look carefully, you see that the largest one is the portal vein, and it is most posterior in the triad. Okay, the middle one in size is the hepatic artery. It's anterior to the left because it comes from the left side. And anterior to the right, the largest duct, which is the bile duct. The smallest duct, sorry. The smallest one is the bile duct, anterior to the left. These are the relations of the portal triad. All of this portal triad is located anterior to the foramen of Winslow. So if you want to expand foramen of Winslow, you cannot go and cut anteriorly because you will injure these structures. Posterior to foramen of Winslow, there is another large vein going all the way up into the heart, the inferior vena cava, the IVC. So posterior border is IVC. Inferior border of foramen of Winslow is this structure. This is the stomach. What's after the stomach? Duodenum. Yes, diaphragm. So So the duodenum is the inferior. And what should be superiorly? This. You see foramen of Winslow? The liver. Okay? So it's the liver. The caudate lobe of the liver, we'll speak about it. So it's the liver. So the borders of foramen of Winslow are very important, as we will see later on. Superiorly the liver, inferiorly first part of duodenum, anteriorly portal triad, posteriorly IBC. Okay? These are very important structures for foramen of Winslow. Keep on going to make things much and much easier now, not just for the cavity, but for the peritoneal, visceral peritoneal covering. We further subdivide this peritoneum because I told you in the pleura it's just one organ, but here so many organs. So we divide the peritoneal covering the organs, okay, with different names. We assign different names to different parts of peritoneum covering different organs, okay, so that to make it much easier to study. So if the visceral of this, but it's the same sac, remember, the same thing, continuous. If it's covering around the stomach, we will refer to it as omentum, okay. So omentum is the peritoneal covering the stomach. If it's covering the small intestine, mesentery. If it's covering the large intestine, mesocolon. If it's covering over a solid organ, like the liver or the spleen, we will refer to it as ligament, okay? But remember, this ligament is 2 layers of peritoneum. It's not a true ligament, fibrous ligament, okay? It's just a name in the abdominal cavity to distinguish this part of peritoneum, okay? Because ligaments usually come from solid organs. But remember, all of these names, omentum, stomach, mesentery, part of peritoneum related to the small intestine, mesocolon, peritoneum related to large intestine, ligaments, peritoneum related to solid organs like liver and spleen. Okay, and all of these structures, remember that they are always has to be double layer. Why double? Of visceral. If they are not double layer of visceral peritoneum, they will not be omenta. Omenta is the plural of the omentum, or mesentery, or mesocolon. Why double layer? Because any organ to become completely covered, you need to cover it from anterior and posterior. So you need at least 2 layers. One anterior, one posterior to the organ. If it's not covered posteriorly, then it's not invested by peritoneum. It will be retroperitoneum. Okay? So if you have an organ only behind the peritoneum, covered just anteriorly, this is behind the peritoneum. There is nothing behind. So in order to become intraperitoneal, as you see in the stomach, for example, we need to cover it from anterior and posterior. Look here to the stomach. To become intraperitoneal, it must be covered by anterior layer of peritoneum and posterior layer of peritoneum. So these 2 layers, if you look carefully, the one covering posterior and the one covering anterior, these 2 visceral layers of peritoneum, I would call them omentum. Okay? This is the posterior parietal now peritoneum, because you see it's covering over the posterior abdominal wall. This is the vertebral column. So this is parietal peritoneum. Follow me. It reflects to become here visceral, but covering behind the stomach. This visceral layer will reflect again to cover anterior to the stomach. And this visceral layer here will continue in the anterior abdominal wall to become parietal. Okay? So those 2 visceral layers surrounding the stomach, I will call them omentum. Okay? So this is the omentum. And these 2 visceral layers will leave the stomach superiorly at its lesser curvature. We will call them lesser omentum. And the ones that will go down from the greater curvature of the stomach, I will call them greater omentum. Okay? So what's the omentum? It's double layer. Always it has to be double layer of what? Of visceral peritoneum. Okay? Double layer of visceral peritoneum that connects the stomach to another abdominal organ. Okay? If you look carefully, the yellow structure here is representing the omentum. So this is the stomach, and the peritoneum will come and cover around it, okay, from behind and anterior. Part of the omentum, as you see, will descend down from the greater curvature of the stomach. So this part, I will call it the greater omentum. While the above that leave the stomach from its lesser curvature, from above towards the liver, I will name it lesser omentum. Okay, the lesser omentum. So I have two omenta, greater and lesser omentum. If you look carefully, the greater omentum, covering or leaving from the greater curvature of the stomach, it first leaves the stomach above, divided into three parts, towards the diaphragm. There it will reflect again to become parietal peritoneum. So I will call it, in this part, related to the diaphragm, this is the gastrophrenic part of a greater omentum, because it connects the stomach superiorly with, the word connect is descriptive also. It doesn't mean there is a true connection. It comes from the stomach and reflects over the diaphragm. Okay, just to make things clear. So this is the gastrophrenic part. The part of the stomach of the greater omentum leaves from the stomach behind towards the spleen. It will reflect to cover over the spleen again. So this will be called gastrosplenic part. So I have gastrophrenic, gastrosplenic, and the largest one here, going down from the stomach, okay, it will go down like an apron, okay, مثل المريل, and reflects back again towards the transverse colon. Then it will cover the transverse colon. So this will be called the gastrocolic part, as you see here. This is transverse colon. It descends, reflects back towards the transverse colon. Then it will reflect to cover the transverse colon. It will become the mesocolon. So this is it. Back again to cover the transverse. So you see, this is covering of the stomach, posterior and anterior. The two visceral layers will descend now down. They will reflect up again. So we will have 4 layers now of peritoneum here instead of 2. And then they will split around the transverse colon to cover it. Now here they become transverse mesocolon. So greater omentum is 3 parts: gastrophrenic, gastrosplenic, and gastrocolic. They all 2 layers of peritoneum with the exception of this. Gastrocolic one is actually 4 layers of peritoneum because it descends and ascends again towards the transverse colon. An internal omental hernia after the lecture. Now, what's happening here? Now, I postpone this, which is related to that peritoneal cavity, until you study the greater omentum. Sometimes part of the small intestine within your abdominal cavity will be looped, تتحرك, and move through the epiploid foramen of Winslow, which we spoke about, into the lesser sac. From the greater sac into the lesser sac. A complicated coiling. Once the intestine gets inside and stuck here, this we call it internal omental herniation. Internal inside the body. Herniation is that hernia. But this kind of hernia is internal. It's not external to the outside. It's within the abdominal cavity and it's related to the omental persa. Omental persa is the lesser sac. So part of the intestine can pass through foramen of Winslow and stuck in the lesser sac. In this case, none of the boundaries of the foramen of Winslow can be incised. Why? If this is the lesser sac, this is the greater sac. Part of the intestine can come up and enter through this opening into the lesser sac and stuck there. You cannot cut any part of here to remove or return back the intestine because the anterior border is the portal triad, as we mentioned, posteriorly IVC, inferiorly شو حكينا? Duodenum, superiorly liver. So how will we remove or return back this loop of intestine into the greater sac from the lesser sac? So what they do is they bring a knife, a small knife, and they cut the greater omentum. You see, this is the greater omentum coming down and reflecting back into the transverse. You cut the greater omentum from anterior here, and you can insert your index finger and push that part outside. Okay? So you aspirate first the gut. Sometimes with aspiration only, aspiration not to show كل شيء inside it. Okay? So it will be collapsed. Sometimes once it's collapsed, it will be reduced by itself. If it's still there, you just need to make what? A small incision in the greater omentum, in the gastrocolic part of greater omentum, and push it with your index finger. Lesser omentum now. This is the lesser omentum. So as the sac covering around the stomach and from the greater curvature, it's greater omentum. From above towards the liver, it is the lesser omentum. Lesser omentum is actually divided into two parts. If we can look to it instead from the stomach, from the liver, حكينا إذا من الليفر towards the stomach شو بصير اسمه ligament. إذا بتطلع عليه from the stomach towards the liver, it will be omentum. So this is the lesser omentum. Lesser omentum extends from the lesser curvature of the stomach and the first 2 centimeters of the duodenum. The duodenum is actually retroperitoneal, okay? But the first 2 centimeters, which are in close proximity to the stomach, they are covered by part of the lesser omentum. So the lesser omentum can be subdivided into the part that comes from the stomach to the liver or liver to the stomach. We call it hepatogastric ligament. Now we are studying the omentum vice versa, from the liver to the stomach. Or the part that's covering the liver towards the duodenum. I will call it hepatoduodenal ligament. Okay, it's a ligament because we look at it from the liver, from a solid organ. So the lesser omentum can be divided into hepatogastric or hepatoduodenal ligament. Hepatoduodenal ligament, which is the last 2 centimeters, the free edge, this free edge of lesser omentum. And actually this edge is forming the anterior border of this foramen. What is this foramen? Winslow. Anterior border of foramen of Winslow. So if you bring a knife and you cut the lesser omentum from here, you will find 3 structures. We call them portal triad. You see? This is the stomach, this is here the lesser omentum. From the stomach to the liver. And it's free margin here containing the portal triad. Okay? This is the other view. If you look carefully, they call these 2 layers of visceral peritoneum from the stomach up towards the liver as lesser omentum. Look to the free edge of lesser omentum here, coming from the duodenum, this part. This is the hepatoduodenal ligament. Okay? And hepatoduodenal ligament containing inside it what? The portal triad. Okay? So if you say the portal triad or hepatoduodenal ligament or free edge of lesser omentum, they all the same meaning. Okay? The free edge of the lesser omentum, which is the part of peritoneum going from the stomach towards the liver. The free edge is this one. The portal triad, these 3 structures going within the lesser omentum, free edge, and the hepatoduodenal ligament is the free edge of the lesser omentum itself. Okay? They all the same meaning. Okay? The same structure. Hepatoduodenal ligament, free edge of lesser omentum equals portal triad inside. Okay? The mesentery, as I told you, it's a little bit more complicated and mesocolon, and they are related mainly the mesentery, the small intestine, mesocolon to the large intestine. To simplify these structures, ligaments related to what حكينا? To a solid organ. راح ندرسهم in details, but the most important two, the one that connects the liver with the diaphragm. So the liver is covered by peritoneum. This part will be reflected towards the diaphragm and anterior abdominal wall. So as reflected from diaphragm and anterior abdominal wall in a falciform shape. Okay? مثل المنجل فبنسميه falciform ligament. So the falciform ligament is the reflection of peritoneum from the liver into the anterior abdominal wall and diaphragm. Add this. Okay? And diaphragm. The other part is the part that hepatoduodenal ligament. سمعتوا فيه؟ hepatoduodenal ligament. طب أضيفوا كمان ligament, hepatogastric ligament. The remaining part of lesser omentum. So it's from stomach to the liver, it's lesser omentum. From liver to the stomach, hepatogastric ligament. Okay? Same thing. Different names for the same structures. So falciform ligament, hepatoduodenal ligament. What are the contents of hepatoduodenal ligament? Portal triad, portal vein, hepatic artery, bile duct. Okay, and third ligament, hepatogastric ligament. In other words, put down same as this omentum. This omentum is the hepatogastric ligament. To make it much more easier, can you سجل الداتا شو الله يخليك؟ خلص. We look to the abdominal cavity in a lateral view at the mid-sagittal, okay, view. طلعوا عليه من الجانب in a mid-sagittal view, okay, to study the parts of different parts of peritoneum. حملوني. So this is the abdominal wall. So now this is the abdominal wall. Inside is the abdominal cavity. Okay. Within the abdominal cavity, you will see different organs. The most important will be the stomach. Okay. So we could see the stomach. This is the end of the stomach. You could see anteriorly what? The liver. Behind the stomach, in the cross section, you can see the pancreas. Below the stomach, there is transverse colon, okay, large intestine. Down below, you will see so many coils of small intestine. Okay. So what will be here? How to stretch the sac, this sac, around these organs. First thing, I need to cover the stomach, the most important structure. So you bring the sac and you cover it all around the stomach, okay? Once you cover it, you will take part of it towards the liver. So now this part between the stomach and the liver, this will be named the lesser omentum, or hepatogastric ligament, the same, okay? Because if we refer to the liver, it's a ligament. If we refer to the stomach, it's omentum. So the stomach is already covered by, as you see, peritoneum. I need to cover the liver. So it will go like this, and covering over the surface of the liver anteriorly. Then it will reflect over the diaphragm here. Okay? As you see, covering over the wall of the diaphragm. Okay? Here inside is peritoneal cavity. This is the other part which will cover around the liver and reflects back again here over the abdominal wall. Now these two reflections of peritoneum, this is a visceral, this is a visceral, that reflect from the liver to the abdominal wall. Two visceral layers of peritoneum reflected, as you see them, from the liver to the abdominal wall. These reflections, double layer of visceral peritoneum, will be named ligament. According to its shape, we will refer to it as falciform ligament, formed like sickle shape. Okay, مثل المنجل. This part of peritoneum, what did we call it? Lesser omentum. Now, from the greater curvature of the stomach, the omentum, this is parietal peritoneum. We agree on this, yes? This is parietal, over the wall. Now this part of peritoneum now will descend anterior to all the intestine. Okay, large and small intestine. This will be the greater omentum, as you see. And extends much larger, far away. Okay? Double layer of peritoneum, of visceral peritoneum from the stomach. However, what's happening here now is this layer of peritoneum, instead of going down, it will reflect up again. Okay? So it will become reflected directly like this. Back again. Towards what? Towards the transverse colon. So now, this greater omentum, it's part of the greater omentum between the stomach and the colon, is actually 4 layers of peritoneum. Okay? What's located here, guys, remember, this is the peritoneal cavity. This is here only adipose tissue, fat, okay, between those layers. So this here, what we will call this structure, again, this should be what? 4 layers now. This is greater omentum. Yes, which part of the greater omentum, if you want more details? Since this greater omentum or gastrocolic, okay, omentum. So this is the greater omentum. So this is the greater omentum. Remember, lesser omentum is double layer, falciform ligament, double layer of visceral peritoneum. Okay, the only exception is the greater omentum. As you see, it is 4 layers. Okay, now these reflected 4 layers, this is which we call it the apron. apron مريالي مثل المريالي بنزل وبيطلع بكل الانتستين anterior to it. Now these 2 layers will separate now to cover what? The transverse colon. So now I have 2 visceral layers of peritoneum covering the colon. These will be named transverse mesocolon. So mesocolon related to large intestine. Okay. Now the 2 layers of mesocolon, once they reach the posterior abdominal wall, they will reflect far away from each other. Now transverse mesocolon become parietal peritoneum. Okay. So this is parietal now. So what's this? This is, we agree, this is mesocolon. Okay. Now the 2 layers of peritoneum, one which will go up as parietal, this is the pancreas. Look careful, it will not cover the pancreas, it will go anterior to the pancreas. So pancreas now is retroperitoneum. Okay? And it will continue as parietal to cover with this one. So we close all this sac now. And this is actually is the lesser sac. You see how it's closed? The other one, as it descends as parietal peritoneum, it will go and surround the small intestine lobes. As it's covering them, it will become what? شوفوا تيجي بتغطي السمول intestine وبترجع. Double layer of peritoneum on small intestine. All of these will be what? Mesentery. So the mesentery is the part of peritoneum covering small intestine, and it returns back as parietal. So all of these now will be named, all of these are mesentery. This parietal peritoneum will continue to close with this part. And the sac is completely closed now. This space containing so many fluid inside it, all of this space, you see it? This is the greater sac of the peritoneal cavity. Greater sac. But this space behind the stomach, all of this space is the lesser. Lesser what? Sac. Remember, distinguish between the sac and the omentum. Omentum is the layer of peritoneum. Sac is a fluid-filled cavity. Okay? It's part of the peritoneum. So this we will complete the journey of peritoneum, and they both, greater and lesser sac, are connected with each other through a small opening. Yes? This small opening, you will usually find it here. Opening from here to here, we will name it Foramen of Winslow. Okay? So this is the whole story of peritoneum. If you look carefully here now, this is the peritoneum. This is covering the stomach, okay? You see the white line here? The white line here reflects from the stomach to the liver. This is lesser omentum. The lesser omentum goes and covers around the liver. As it covers here, this reflection here and here together will be the falciform ligament. Now this is the anterior part of parietal peritoneum, going down, okay? This here, the two reflections go down now. This is greater omentum. Going down reflects up again. So here we have 4 layers together. Then it splits to cover the large intestine. So this will be mesocolon. The mesocolon will reflect down on the peritoneal wall here, on the abdominal wall. It will become parietal peritoneum. Upper layer of parietal peritoneum, this is the pancreas. That's anterior to the pancreas. So pancreas is retroperitoneum. And this parietal layer will continue with the upper parietal layer here, and this complete closed sac is the lesser sac, as you see. Okay? The other layer now will reflect down and go to cover the small intestine, as you see. As it covers the small intestine, all of these we will name them mesentery. After it covers all of these mesentery, it will return to join the parietal layer of peritoneum again. Okay? And all this space in blue, as you see, is the greater sac. This one is the lesser sac, and here you can see the foramen of Winslow connecting the greater with the lesser sac. And this yellow structure is the adipose tissue between the layers of peritoneum, as you see, in the empty spaces. Now, peritoneal nerve supply is important. Remember, we have parietal, we have visceral. Parietal is an attachment to the abdominal wall. So the innervation to the parietal peritoneum is the same innervation to the abdominal wall. So it's somatic. Usually somatic. يعني general sensation, not autonomic. Okay? So you can feel pain. Okay? The same as you feel pain in any region. So it's innervated in peritoneum usually by T7 to T12. Okay? The innervation from T7 to T12 and the first branch of L1, iliohypogastric nerves. Okay? We will cover this when we go over the abdominal wall in the upcoming lectures. But the visceral peritoneum, what I want you to distinguish is that parietal somatic. There's pain in that part of peritoneum, you will feel it there. Okay? Visceral peritoneum is different because it's covering the organs. So innervation to the organ, covering, for example, the stomach, there will be innervation to the omentum. Okay, it's the same the organ it covers. So it's a visceral. Visceral دائما كيف بيكون البين؟ ما في بين. Okay, it's vague and referred pain always. Okay, so it's part of autonomic innervation, not somatic. Visceral, not somatic. Organs relations to peritoneum. بالترتيب الستومك أكيد intraperitoneum. Duodenum is retroperitoneal. Okay, except for the first 2 centimeters. It is a secondary retroperitoneal structure. Now this is up for more. There are primary and secondary retroperitoneal structures. What's the difference between primary and secondary retroperitoneal structure? Duodenum is a secondary retroperitoneal structure except first 2 centimeters, which is the free edge of the lesser omentum. I show you. Containing the portal triad اللي اسمها hepatoduodenal ligament. The same thing. 3 structures are the same thing. Jejunum and ileum are intraperitoneal. Cecum. Now remember, you remember when we spoke about the esophagus in the previous time, we said in order to transmit from striated muscle into smooth muscle, you need a gradual transit. Now, in order to become from intraperitoneal structure into retroperitoneal structure, you cannot come abruptly. You need also a gradual transformation. This happened from small intestine into large intestine in the cecum region. So as the peritoneum covering completely, okay, as it reaches the cecum, it starts to separate from the cecum. So the cecum is covered, but not completely, just anterior lateral. Okay? Not completely. So it does not have a mesocolon because cecum is part of large intestine. It does not. It's partially covered with peritoneum. Okay? Because the ascending colon after the cecum will become retroperitoneal. It's not covered. Okay? So the cecum is partially covered by peritoneum. Okay? So we say in other textbooks you see that it's covered with peritoneum but does not have mesocolon. Okay? Appendix, what is the appendix? Exactly. It is intraperitoneum. So it has a mesoappendix. So this is important during appendectomy procedure. You have to ligate the peritoneum. No cutting. Okay? The ascending colon is retroperitoneum. Transverse colon intra. شفتوها فرجيتكم اياها بالرسمة. Transverse mesocolon. Descending retro. Sigmoid colon intra. Now after the sigmoid colon we have the rectum. The rectum will pass where actually? In the pelvis, not in the abdominal cavity. So the first part of the rectum, upper third, will be covered anterolaterally. So it's partially covered by peritoneum. The second third of the rectum will be covered only anteriorly. The third part will be in the pelvic cavity, below the peritoneum. So it's not covered by peritoneum. It's subperitoneal now. The term subperitoneal means it's below the peritoneal cavity itself. So the rectum is three different structures. Liver is covered by peritoneum except over three areas. We will study them. One is called the bare area of the liver. The second one is where the portary triad enter and leave. Because if they are covered by peritoneum, these portary triads cannot get into the liver. You need to get them. So you remove the peritoneum to get it. So it's called porta hepatis, or the hilum of the liver. Okay? And where the gallbladder is resting. Because once there is a gallbladder over the liver, peritoneum cannot come in between them. It will cover over the gallbladder. But if you remove the gallbladder, it's still rough surface of the liver down it. So three areas. The bed for gallbladder, the opening for portary triad, hilum of the liver. Any organ in anatomy has a hilum, by the way. You know what hilum means. Lungs, they have a hilum, إذا سمعتوا فيها. Okay? شو كمان? Kidneys has a hilum. Kidneys, they have a hilum. Liver has a hilum. Hilum means the gate, البوابة, where structures enter and leave that organ. Okay? These structures are the vital structures, the vein, artery, nerve. Okay? And other important structures related to that organ. So the hilum of the liver, the bed for gallbladder, and the bare area of the liver. Pancreas كله retroperitoneal except for the tail. Except for the tail. The tail of the pancreas is intraperitoneal. Okay? If you need more explanation, I can tell you why after the lecture. Spleen is intraperitoneal, as I told you. Kidneys, primary retroperitoneal structure. Primary retroperitoneal structure. Your homework is to know what's the difference between primary and secondary retroperitoneal structures.